All right, so let's get back into the second part of this chapter. And what we want to look at today are types of double bonds. Types of double bonds. Okay. So let's draw some types of double bonds. Okay, so if you look, there's the double bond, and I'm just going to add on different carbon groups here. There's some different types of double bonds. Okay. Carbons on there. Let's look at this one here. How many carbons are on this double bond?
3.
How many carbons are on this double bond?
One.
One. Okay? So if there's one, we say that this is a mono substituted. A mono substituted double bond. Okay. How many carbons are on this double bond? 2. 1 and 2. This one down here has 2. Okay, so here's two different ways of having 2 on this one. And so this is what's called a di-substituted double bond. This one here has 1, 2, and 3. So that's a tri-substituted double bond. And this one here has 4. And so we call that a tetra-substituted double bond. Okay? So make sure you can identify double bond types. Let's look at an example. Let's suppose I gave you that alkene. What kind of double bond would that be? You got 4 options.
Substituted.
Got 4 options. What was that? This would be a di-substituted. Okay, so here's the double bond. I got 1 and 2 carbons on it. Okay, so that would be di-substituted. Okay. So make sure you can label the types of double bonds. We'll get more practice a little bit later. But there turns out to be a stability order to these double bonds. It turns out that the more carbon groups on the double bond, the more stable. So a tetra would be the most stable, and the mono would be the least stable. Okay? And the other two are in between. Okay? So stability of double bonds, okay, has to do with these two carbons of the double bond are sp2, so they're a little bit electron deprived. And when I have carbons on there, they can donate electron density in to help stabilize the double bond. Okay. Anyway, all you want to do is remember the stability order. Okay? We're going to make use of that starting right now. Okay? So remember last time we looked at the E1 mechanism. Now we're going to look at the E2 mechanism. Okay. So if you want to scoot over, messed it up. Now I don't know where my markers are. Can you see that?
Yeah, still got it.
I don't know how much space is over to the left.
You still have space?
They messed it up. Now I don't know. I don't want you to touch the camera, because now I don't know how far over. Okay. So let's look at the E2 mechanism. Okay, so here is the setup for E2, which is very similar for the SN2. Okay. Why would this be a good SN2 by way of review? You got a strong base and a primary substrate. Okay. So you can do a very easy SN2. To get those products there. But I'm not worried about SN2. We want E2. Okay, you get to show off your SN2 today at 3 o'clock. So let's look at the E2. Okay. So just like for the E1, we attack a beta hydrogen Okay, so it's beta because it's next door to the leaving group. Okay. And then these electrons dump in to form the double bond. And then the leaving group leaves. Okay? So you get all that going on at one time. Remember last time with the E1, it was the same thing, except you had a carbocation here. Okay? So as a result, we end up getting an alkene double bond. Okay. So both SN2 and E2, all this occurs one step, one transition state. Okay. You might ask, well, since you can get both products, what product do you get? Answer, you get both. You get a mixture. Okay? We just didn't realize that when we did SN2s. Okay? But now we realize we can start getting this alkene product form. Okay? So this is the mechanism of E2 that you want to have down for the next test. Okay. So let's do this, another example of this on another molecule. This one here. Question? Okay, yeah, that's what we're going to look at. Okay, so in this reaction, what do you see? You have two different sets of what? Beta hydrogens. Okay, so that's what you want to be on the lookout for. We saw this last time with the E1, but just look at the leaving group, look to the left, and you look to the right. So I see two different sets of beta hydrogens. So I got two different spots where my base can attack. So I can maybe call these the A hydrogens and those the B hydrogens. Okay. So let's draw both attacks over here. If the base attacked the A beta hydrogen, where would the double bond form? Right there, and kick that bromine off. And so we would get that alkene, where the double bond is forming here. And this stays CH3. If I did the B attack, then the base would take this beta hydrogen form a double bond here, kick the bromine up. So I would get those two possible products. Okay, and we saw this last time with E1, that we could get two possible products, but now we want to talk about it in a little bit more detail. When you can get two products, you always want to ask which one can form more, which one forms less. Okay? The one that forms more, we'll call that the major product. The one that forms less, we'll call that the minor product. Okay? Which one of these do you think will form more? Any idea?
I think
A or B?
B.
Okay. Well, let's answer it in logical steps. What kind of double bond is this one?
Di.
That's a di substitute. What kind of double bond is that? That's a mono substitute. Which of those two is more stable? Di. So which do you think will be the major? The di. Okay? Yeah.
The process of doing E2 the same as like doing SN2, like nucleophile protection by and everything.
Okay, so the nucleophile is attacking a beta hydrogen. So that was for the B attack. The A attack, boom, boom, boom. Okay, so this here introduces an important rule. That's called Zaitsev's rule. Zaitsev's rule. I will repeat this rule 2 times, so you have 2 chances to write it down. Though you can already write it down, as we've already stated. Okay? Here we go. Zaitsev's rule is that in an elimination reaction, the more substituted double bond is the major product because it's the more stable double bond. See, somebody didn't even write it down at all. All right, that's fine. It's your choice. Second time. Zaitsev's rule states that in an elimination reaction, the more substituted double bond is the major product because it's the more stable double bond. Okay? If you missed it, it's in the book. Okay? If you don't like writing things down. Okay? A very important rule. Okay? very important rule. So this is the important rule out of chapter 6. When we get into chapter 8, we're going to see another important rule called Markovnikov's rule. Okay, we'll deal with that later on. Okay, so know how to use Zaitsev's rule. Okay, and know how to draw the E2 mechanism. Know how to draw both products. Know how to analyze both products and figure out which is the major, which is the minor. Okay? Let me give you one to do here. Okay, this is right out of your book. Okay, so see if you can draw the two possible products and then which is the major and which is the minor product. So obviously here you'll first have to draw what 2-bromo-3-ethyl pentane is, and then go from there. I hope you can draw these molecules. You'll be given practice on the exam today, doing so. Oh.
Jumping off the wall.
Okay. Did you make any progress back there? Any progress?
A little bit.
Okay. Why don't you come up and draw the beginning molecule? See if we can do this in pieces here. Draw it underneath there. Okay. All right, very good. Do you want to take it any further, or is that good enough right now?
It's good enough.
Okay, all right. All right. Yeah, let's see. Okay, you had too many hydrogens here, so I need to take this one away. Okay? But that's where you gotta start. Okay, so we want to come up and draw the two possible products. Any volunteers before I call somebody? Draw underneath there. Okay, very good. Which one's the major product?
And that should be the first one,
Okay, very good.
because we have the dye.
Try. Try.
Try and this one.
Mono. Okay, very good. very good. So let me redraw them here just to magnify the picture. Okay, so these are your two possible products. This is the tri. This is the mono substituted. Okay? Any questions at that point? Yeah.
Could you go back a step and show me where the arrows are leading away from, like the leaving group and the,
Okay.
because I don't see where the beta hydrogen is
Yeah.
coming from.
Yeah. So let's highlight them here. So there's the two beta hydrogens to attack. Okay? So if the OH attacks this one, double bond, kick off. If it attacks this one, double bond, kicks off.
So beta hydrogens are going to be on the opposite sides of the leader.
That's right.
Okay.
Okay? Any other questions on that? How many of you got those two products? Okay, a handful, not bad. All right, so
What about the other products, will combine together?
yeah, those are just some. Yeah, these are the only things I'm concerned about. But yeah, you get sodium bromide as a side product, but we don't worry about that. Okay? So make sure you can do the E2 mechanism, okay? And spot out the major and the minor products based on the double bond types, okay? So that's all we're going to do today. Next time, we're going to look at a little twist in the E2, okay? So make sure you don't miss the next lecture on Friday,
Well, we
okay?
can't get Friday off, we're gonna have our test and take spring break.
Okay. Better turn the camera off.